Have you ever wondered about the biggest explosions in the universe? Let's journey together into the vast cosmic landscape, a realm where celestial bodies don't just twinkle, but explode with a force that's hard to fathom. A universe teeming with energy, where stars don't merely fade away, but go out with a bang. These spectacular events, known as cosmic explosions, come in all shapes and sizes. From the relatively small nova, a sudden brightening of a star, to the colossal supernova, an explosion of a star at the end of its life cycle. But beyond the supernova, there's an even more powerful event. An explosion so massive, it makes a supernova look like a mere firecracker. An event that can outshine an entire galaxy, releasing more energy in a single moment than our sun will in its entire lifetime. Hypernovae, these are not just your average supernovae, but something far more powerful and extraordinary. So, what exactly is a hypernova, and how does it occur? Well, a hypernova, also known as a superluminous supernova, is an explosion that occurs at the end of a massive star's life, but it's not just any explosion. This is a cosmic event of epic proportions, an explosion so powerful, so immensely energetic, that it outshines the entire galaxy it resides in. Now let's delve into the life of a star and see how a hypernova occurs. Stars, much like us, have a life cycle. They are born, they live, and they die. But unlike us, a star's life can span billions of years, and its death can be a spectacularly violent event. A star begins its life in a nebula, a vast cloud of gas and dust in space. Over millions of years, gravity pulls this gas and dust together, forming a protostar. As the protostar continues to gather more material, its core becomes extremely hot and dense, sparking nuclear fusion and giving birth to a star. The star then spends most of its life in a phase called the main sequence, where it burns hydrogen in its core to produce helium and energy. This energy, in the form of light and heat, is what makes the star shine. After the hydrogen fuel is exhausted, the star expands and becomes a supergiant. Now, for a hypernova to occur, the star needs to be at least 20 times the mass of our sun. In these massive stars, the core eventually collapses under its own gravity, triggering a cataclysmic explosion, a hypernova. This explosion is so violent, so intense, that it releases a staggering amount of energy. We're talking about an energy output that's hundreds of times greater than a regular supernova, and the light produced, it's so bright that it can outshine the entire galaxy. But remember, this isn't just a spectacle of cosmic fireworks. Hypernovae play a crucial role in the universe. They produce and distribute heavy elements throughout space, contributing to the formation of new stars and planets. So, a hypernova is a cataclysmic event marking the end of a massive star, resulting in an explosion of such magnitude that it outshines an entire galaxy. What happens after these colossal explosions? Well, the aftermath of a hypernova is equally fascinating and consequential. When a hypernova detonates, it doesn't just disappear. Instead, it leaves behind a dense, compact remnant. This could either be a rapidly spinning, highly magnetized neutron star, or a black hole, an entity with a gravitational pull so strong not even light can escape. But there's more. The force of a hypernova explosion also disperses elements across the universe. The stellar debris, rich in elements heavier than helium, is hurled out into space at incredible speeds. This stardust then becomes part of interstellar clouds, the birthplaces of new stars and planets. In essence, every time a hypernova erupts, it enriches the universe with a chemical diversity that underpins the formation of life as we know it. So these cosmic fireworks are not just spectacular shows, they are crucial for the universe's evolution and diversity. Let's take a step back and summarize what we've learned about hypernovae. These are not your regular supernovae. No, these are the universe's biggest, most powerful explosions, dwarfing their supernova cousins in both scale and energy. They occur when massive stars, larger than our sun, exhaust their nuclear fuel and collapse under their own gravity, triggering an event of unimaginable power. These hypernovae play a crucial role in the evolution of the universe. They seed the cosmos with heavy elements, building blocks for new stars, planets, and potentially life. The aftermath of such an explosion is a sight to behold, leaving behind exotic remnants like neutron stars or black holes. The mysteries of hypernovae continue to unravel, offering insights into the universe's past and hints towards its future evolution. So next time you gaze up at the stars, remember the cosmic drama that unfolds across the universe. Hypernovae, the biggest explosions in the universe.